Hello everyone, welcome to another video. We will be solving differentiation question and definitely for all the parts we need to differentiate the equation, polynomial equation, and after that we need to find the stationary points, the minimum and maximum point, and we also need to find whether the turning points are they minimum or maximum. So let's differentiate quickly. In order to differentiate, definitely you need to use a pattern. So you can write this question as d over dx, and you need to differentiate x cube minus 4x square minus 3x, extend the line, and definitely power reduces by 1 and power comes in the coefficient behind the variable. So this is going to become 3x square, this is going to be 4 to the 8x, the power reduces by 1 and minus 3. Now we have got this as an equation which is basically the differentiated equation, and this is the answer for part 1. Let's move on to the next part. The curve is an equation, the same equation. Work out the coordinate of those two stationary points. Show all your working. So this is quite easy. We can solve this now. In order to solve this, we can use the differentiated equation and equate this equation with 0. So we have this as a quadratic equation now. Quadratic equation को हम 0 से equate करते हैं. In order to find the turning points, we need to differentiate an equation, and if this is a quadratic equation, we need to equate this with 0. And now I can clearly see we can also use the Middleton break or completing the square method, or if you want to use quadratic formula, that's totally up to you. I might try using Middleton break. So let's see, 3 3 is a 9, and 9 has factors 9 1 is a 9, 9 and 1. And if we talk about 3 3 is a 9, 3 and 3 can be another factor which makes 9. So I think 9 and 1 can be used, and let's see if this is going to work out. 3x square minus 3 can be written as this. We can break the middle term into two different parts. That means minus 9x plus 1x. So let's see if we are getting the same brackets. Let's take common. 3x will be common, and this is going to be x minus 3. And when you don't have anything common, so you can take 1 as common from the next two terms, and this is going to be 1. Everything remains inside the bracket same. X minus 3 comes as it is and equals to 0. Yes, this can be solved through Middleton break because we are getting the same brackets. Now we can write one of the brackets which are common. So x minus 3 is common, and we can also write 3x plus 1 equals to 0. Now we have this as two brackets. We can equate both the brackets with zeros, and definitely we'll get the value of x. So in this regard, the value of x is going to be 3, and another one is going to be minus 1 over 3. So these are the two values which you will be using to find the value of y. You can substitute these values back into the given equation, the main equation, which is the main equation, the question which is given to you, the equation of a curve. You can substitute these values back into this one. So let's substitute one by one. I'm going to remove this for now. Just delete this. We don't okay. So let's substitute x equals to 3 in the main equation, and then we will do the same thing with minus 1 over 3 as well. So let's substitute the value of y in this one, which is going to be x cube minus 4x square minus 3. Whenever we have x equals to 3, I'm going to substitute the value of 3 wherever we have x. Minus 4, 3 to the power of 2 minus 3. 3 to the 3 is a 9, 3 9 is a 27, and 3 3 is a 9, 9 4 is a 36, minus 9, and that comes to 27 minus 9 minus 8. It should be negative 18 as an answer. So the first coordinate you have is 3 comma negative 18. This is going to be the first coordinate, and definitely you can write in here 3 comma negative 18. And if we talk about the same thing, we'll substitute x equals to negative 1 over 3 in the same equation. So I'm going to do this again. Whenever you get the values of x, you can substitute in this main equation to find the value of y. The y, basically the value of y, the turning point, the highest or the lowest point can be. So I'm going to substitute x equals to negative 1 over 3. This might be a little bit complicated, but let's see how we solve this one. So minus 1 over 3 to the power of 3 minus 4 comes as it is, then again minus 1 over 3 to the power of 2, and minus 3 into minus 1 over 3. 1 over 3 is the value of x basically. Now whenever you have a odd power, your sign inside the bracket remains same, minus remains same because minus into minus into minus minus, 1 remains same because whatever you have as a power 1 doesn't matter. 3 3 39, that's 27. This is going to be 27. Minus 4 comes as it is. Whenever you have an even power, everything become positive, so 1 over 9 in this case. 3 3s are 9. And then if you move forward, 3 can cancel each other, minus minus will be positive, and that's positive 1. Let's simplify this one out. Minus 1 over 27, minus 4 over 9, 100%, and positive 1. We'll take an LCM. If you want to take LCM, or if you want to do it other way, into 3 makes 27, into 27, into 27. So finally I can see y should be equals to, we have the common denominator now, 27 comes in the denominator, minus 1 minus 12 and plus 27. 13, it should be 14 over 27, and this is going to be your y coordinate of this value of x. So now you have another coordinate which is negative 1 over 3 and 14 over 27. So these are the first two parts, and definitely we have figured it out how do we solve for the two stationary points. And the next video I'll be telling you how are we going to find the minimum and maximum points. Thank you so much guys.